Here is a DNA sequence. It must be transcribed into messenger RNA so that it can leave the nucleus and travel to a ribosome to be translated into amino acids. The amino acids will form a polypeptide chain, creating a protein. Point mutations can occur in the DNA sequence, which is when one base is changed or substituted for another. Point mutations can lead to changes in the resulting protein. 4 mutations will be looked at today: silent, missense, nonsense, and read-through. Silent mutations are categorized by no change in the coded amino acid. Spontaneously, deamination of cytosine can occur in the DNA sequence. In the coding strand, the cytosine-guanine pairing changes to a thymine-adenine bond. This is what's known as transition, since the cytosine changes to a thymine, going from pyrimidine to another pyrimidine. After deamination, there will be a different codon in the mRNA transcript, but the same amino acid is coded for. In the mRNA, the previous cytosine is now uracil. UGC and UGU both result in the amino acid cysteine. Missense mutations are categorized by a change in the coded amino acid. In this example, what used to be cysteine is now arginine thanks to mispairing of bases due to wobble. Wobble in the DNA sequence allows thymine to bond with guanine. A guanine in the template strand will bond with cytosine in the coding strand, representing a transition. The original DNA sequence had a thymine, and the resulting DNA sequence has a cytosine. One pyrimidine changed to another pyrimidine. The mRNA transcript went from UGC to CGC, changing cysteine to arginine. Nonsense mutations are categorized by the changing of a codon that codes for an amino acid into a stop codon. In this example, the mRNA transcript changes from UGG to UGA. UGG coded for tryptophan, but the new codon UGA codes for the end of translation. Alkylation can occur in a DNA sequence where a guanine is transformed into an ethylguanine. This ethylguanine bonds with thymine instead of cytosine. Through replication, where there was a guanine in the coding strand, there is now an adenine. Similarly to the mutations thus far, this represents a transition. Guanine to adenine is a purine changing to another purine. Read-through mutations are categorized by the changing of the stop codon into one that codes for an amino acid, meaning translation continues. In this example, depurination occurs. The bond between guanine and cytosine is broken, and the guanine is removed from the DNA sequence. There is now an apurinic site in the sequence. Through replication, a new nucleotide is incorporated into the DNA, adenine in this example. Through another round of replication, a thymine is now in the coding strand, where there once was a guanine. This is a transversion. Guanine, a purine, changing to a thymine, which is a pyrimidine. Where there once was a stop codon, there is now a codon that codes for leucine.